Okay, so let's start with sharing my screen so that everybody will be able to see everything that I'm doing. So in the meantime, waiting for that to load, I press share. I just realized that since I didn't make a single slide, I didn't make any introductory slide either. So because of that, what we're going to introduce with is your own GIF reactions. And your own GIF reactions are a transformers from the animation and a transformers that's more likely going to be like what this talk's going to be about. But I don't have slides. I do have this pretty drawing. If you can't see it, please let me know by shouting. So transforming code into other code. First, let's talk about why you would even want to do that. And why do you want to transform code into other code? That has multiple reasons. You maybe want to save time. So you want to write something only once and then be able to have multiple outputs for that. Or you want to prevent mistakes when you have duplicated code, easier updating, more ergonomic API than what you normally expect. Those things are key points that actually you could have given for any abstraction. Any function can save you time, can prevent mistakes when you have duplicated code, etc. However, what we're really interested in is preventing those things from actually having a runtime overhead on our code. But before we'll dive deeper into how we'll do this, I'm going to explain you how this works behind the scenes. And for that, we need a little bit of theory on compilers. And I know compilers are kind of a scary topic. It's not too simple. However, there's only one part of it that you really need to understand now. And that part is the AST. AST stands for abstract syntax tree. Now that sounds like a pretty abstract word, and that's okay. But if we look at a piece of code, then an abstract syntax tree would be taking that code and walking over it, and then you will go to each part of it. You will take, for example, the console, which is an object, and the dot is a separator, the log is a member, the parentheses are parentheses, and the quotes are the start of a string. At the end of the day, you will have a little map, a tree of all of the different things of this program, a different representation that is no longer text, but now that is structured. And the way that this is structured, it's actually pretty interesting that this is in a tree, because that means that you can use all of your algorithms that you know to walk trees. So you go to the next thing, whether you do that deep first or breadth first, that's kind of out of the question now. But what's important there is that you can transform this tree into another tree and then make that back into code. And that's where the power lies. Now, if you want to know even more, I advise two resources here. That's astexplorer.net and the Super Tiny compiler. If we'll, oh, I went the wrong way. The Super Tiny compiler is an amazing resource that just in an hour or something, you can read and really understand all the terminology that is relevant for compilers and how that relates to yourself and to your current day job. AST Explorer actually gives you a representation of this AST. For this case, this is for JavaScript. However, there's also versions for some other languages. As you can see, basically, we'll have a comment node here, a comment block, and we will have an identifier and another identifier. Most of the things are called identifier, let's be honest here. But that's the first step. The first step is understanding that you can go from code that is text and is kind of hard to modify to go towards a structured piece of data that you can modify things at. So if you want to learn more, you can use those resources. So this should be enough to get us all a bit started on actually doing code-to-code transformations. And there's multiple types of those. The first type of transformation you could do is enabling new syntax to your code. Examples of that would be JS6 or question mark dot. Unfortunately, those are really tough to do, and I would disadvise you to go that route. The main reason is that code usually, a programming language at least, usually has syntax highlighters and has other tools that rely on a code being how it is expected to be. If you try to mess around with that in a programming language where that's not part of the core of the language, then you will have many, many issues. And I would advise you to only do those kind of things that are already chosen as valid by the community. However, if you're using another programming language like Rust, and I think C++, which has templates and macros as part of the programming language, really allows you to go further that and add your own syntax there. However, we're talking here about JavaScript, which doesn't really have those capabilities built in. But what can you do then? Well, the next thing you can do is do certain transformations from JavaScript still to JavaScript, but do them on every build. Examples of those are minification. So you write your code normally in a pretty way, with indentation and all of that, but for the users, that doesn't matter. Users do not care about the indentation or don't care that you have multiple files. So there's multiple tools that use minification. Basically, they will create an AST, and then they will throw away everything which is spaces, and they can go even further than that. They can try to find whether things are constant expressions or dead code, and they could just throw them out of your final file, and then you have a smaller file. Another option there, or another thing that you probably already do if you do JavaScript, is using babel to transform newer syntax back into older syntax so everybody can use it without having the support of the newer syntax itself. So we can go further than that. This is like the default. That's the little baby version of transforming code into other code. The next step is the toddler version of transforming code into other code. And that is actually just taking the abstract syntax tree, walking it over it, like walking down the tree, and then trying to find certain expressions or certain patterns that are disallowed and can then be changed into ones that are. Examples are for JavaScript with linting, you can disable console log, or not necessarily disable it, but warn for it. And you would do it specifically in this way, where you would walk all over the tree, find everything that's called console. Remember that those things are called console. Then find everything that's called log as a member of this. And then as soon as you find that, you can put some warning. We can go further than this though. We can create code from data. A good example for this is actually not in JavaScript as this example, but that is in C++ and Ruby, and that is in our own engine. The way that, I don't know if you've ever tried this, but in the Algolia engine, you can type emojis just literally the emoji, and you will get results for the textual representation of this emoji. In this case, that would be hanky or smiling face, no, smiling poo with face, and diamond. But if you're in a really high performance case, like our Algolia engine is, you can't just go to the internet and go and ask, hey, this emoji here, what's the text for it? So the way that that this works is by taking a big text file, which you can find from unicode.org, and then we will read that at one time. We will go find every case of a letter or a character which is an emoji, and then there's a file that has all the descriptions written next to it. And then instead of at runtime trying to find every character's representation as text, what we can do is one time we will take from that text file, we will make a new code file, and the code will then contain probably a map that says this character, this is the textual representation. So that's already one use case. Another use case is with macros. If we look at macros, which I mentioned earlier already, are a feature of many programming languages, they're also a feature of Babel, a common code transformer for JavaScript. If we see an example here, and as a coder, I don't really want to write 24 times 60 times 60 or have a magical number here that says 86, 4, and then 5 zeros to say that something is a day. What I'd rather have is in my code, I say that it's a day, but the code that actually gets run by the users, I'd rather that to be something simple, something static. If you want to create a macro like this, you can do this with, oh, that's the wrong one, with AST Explorer, which actually gives you access to Babel plugin macros. So what we have here is a program which will walk the tree, then allow you to do whatever you want with it, and you just have the code. And after that, it will output the new AST that you have just changed. In this case, from going from an import, and that's a specific way that macros manage to get themselves to be more self-contained. If you import something, then you can find all its references. The reference here is this call, get the arguments, etc. In this case, what you would do is you find all the paths that are this MS, you get the value of that, which allows you to get the arguments, for example. In this case, I didn't implement it all the way because it's a chunk of code, but you could use any type of library you want there. There's runtime libraries for transforming strings into numbers, in this case of dates, of course. But then what you do is once you find this new value, you can replace it with a new numeric literal, and that's it. Otherwise, throw an error. And what you can see here is that this here transformed into this number. In our case, I just made that a number, but I can also make that math random. And now it will get executed. Every time I do a change here, that's a new execution. The way that this will integrate into your normal build system is that this will get executed every time you build, like you minify, etc. And there's also more things. You can mark code specifically as being for development or being for production. A nice example here you can find in a Babel plugin that we have in the instancer.js code base, where we have a warning code. I'll write that down so you can keep following. Warning, which is a little helper that accepts a Boolean. And basically the warning will only be thrown when that Boolean is true and only in development mode. And then the actual warning would be there. However, what you would usually want, and there you can go very far with the macros, is that not only does the code not get run in the production mode anymore, which you can do with your check, but you also want that code to be eliminated from the production build. Now, the minifier that we used already had dead code elimination. However, this isn't per se dead code. This Boolean still gets passed to the other function, and only then we choose that nothing happens. It's not dead code. The solution there is to find all the references of warning and replace them with if development, only then we do the warning. Then later, when we do the production or development build, the minifier will be able to find everything that is always going to be falsy, because it will basically replace this global variable with false in production mode. And then if you have an if false, then you can just as well get rid of it. If we go further, there's actually more than doing stuff on every build. There are some things that you only want to run once. If you want to run something just once, what I'm thinking of mostly is upgrade scripts or migrations. There is another tool here that basically is called, it's called JS Code Shift, and it's built on top of Recast, which also takes in an AST, and in this case, it's a slightly different one. But you will be able to find, for example, every call expression where the callee has the name which is from, and replace that with a member expression that is your to, and then the arguments are put inside an array. And that is what we can see here. We replace add widget, two add widgets with a plural, and put them between an array. Once you have a script like this, you can just wrap it up in a little command line, and you can send it to your users to be able to quickly upgrade from one thing to another. If all that you changed is maybe names or small syntax changes like we did here. React itself also has some code mods to help with, for example, going from a class-based system to a function-based system, and then to continue from there. Now, I hope that this was all useful. I especially advise you to go look out AST Explorer if you want to try out more things, and read the Super Tidy compiler if you want to learn more about compilers in general. And I'm going to stop sharing my screen now because that was all. I don't know how to stop sharing screen. Okay. So there's a few questions here where I will look into. First question is from Jerome. Indeed, you can go from code transformation, but you can also generate new code. There's always lots of options for you to go further, because code and itself is a data structure, and a data structure you can change to another one and then create a new one. So let's look at that. Anthony is asking me where I created my graph for the presentation. That was done with Excalidraw. I'll write it down so you can remember it. Excalidraw. The next question is from Anthony as well. How could we leverage code generation in instance search libraries? That is an interesting question. A common thing where we're already experimenting with that is the migration scripts, where you can go from one version to the next version without the user having to find everything. The other option will be things where we can have shorter piece of, like a more concise piece of code that behind the scene does a bunch of function calls, for example. But in the end, we want to get to something that is more repetitive, because that's what that's what actually works. Then we can cut out the overhead of those function calls and do that all at build time instead of at runtime. The next question is from Mathieu about what's a React code mod. Sorry for not being too clear about that. That is code mod specifically for React. So transform from the class to functions, or similar things. Yeah, I think that's the questions that are there. If there's any more questions, you can of course always ask them now via chat if you want to do it quickly still, or do it afterwards. Yes, Lack.